All right, I'm going to teach you 5.2 direct variation. If it looks like there's some more written than usual for notes, it's because I did this entire set of notes and recorded it and everything, but I didn't have the mic on, so I couldn't hear anything. So I'm doing it all again. So here we go. Whenever we're doing direct variation, we're going to use this equation y equals kx generally. And the k is called the constant of variation. It seems like a paradox, but constant in math, or really in everything, means it stays the same. It doesn't change. So k is the one thing that stays the same in the midst of change. So as x and y change, the k stays the same once we establish what it is for a particular problem. Okay? All right, I wanted to start off with an application. So let's say we exercise, and we would say that the number of calories that you burn exercising varies directly with the number of minutes that you're exercising. So if you exercise for more minutes, you burn more calories, of course, and so that relationship is a direct relationship, direct variation. So if you are right here at 0, 0, that means you're not exercising at all, so you burn no calories. And let's say we pick an exercise that's really rigorous. So if we only exercise for 5 minutes, then we burn 50 calories. So there is that point, 550. And if we exercise for 10 minutes, let's say that we burn 100 calories. That's quite a bit of calories to burn just for 5 minutes of work. So it's probably a fairly rigorous exercise. And then 15 minutes, we would burn 150 calories, and then 20 minutes, we would burn 200 calories, and you get the picture. Now, let's say we wanted to write an equation that would describe the number of calories that were burned all the time. Well, let's say that y equals the number of calories, because it's already on the, this is already on the y-axis here, calories. And then the x-axis, let's say that this is the number of minutes that we are exercising. So all of these problems, we start them off with y equals kx, assuming that we're using the letters, x and y for our problem. So we have y equals kx. And really all we need to establish our constant of variation is we need one good point. So let's use the point 550, and let's plug in 50 for the y. And we don't know what the constant of variation is, but we do know that whenever we want to burn 50 calories, we got to exercise for 5 minutes. So let's try to figure out the k. So we divide by 5, and so k equals 50 divided by 5, or, so this is 50 divided by 5, or we would say that the k is actually 10. Now, the k actually means something in this problem. The k is how many calories you burn, so this is 10 calories that you actually burn per minute. So it's a rate. Remember how the slope is a rate of change? So 10 calories per minute is the rate at which we're burning calories for this particular exercise. So we can look and see that that's also the slope of the line. So we go up to get from one point to the next. We go up 50. We went from 50 to 100. So we go up 50, and then we go over 5 minutes. And so we can see that the slope would be 50 over 5, which is 10. So we have a slope of 10. Again, that's actually the k, which is the constant of variation. So for this red line, the k is 10. It's the constant of variation. All right, let's move to the next problem. Let's say they ask you to graph. They just say, hey, this is a direct variation equation. It's y equals 4x. We'd like you to graph it. Well, these are among the easiest things to graph, really, because all of the direct variation equations, they go through 0, 0, and all we have to do is get one other point. So always look at the number that's right in front of the x, and that's the slope, and it's also the k. Okay, so I'm going to call it the slope for right now, because that applies for the whole chapter. So that's the slope, which is also the k. And if it's not written as a fraction, just write it as a fraction, because that'll help us figure out how much we had to rise, how much we have to rise, and how much we have to run to plot the points. So the top number is the rise. So we have to rise 4 units, and then we have to run 1 unit. So we'll start right at the origin, and we'll go 1, 2, 3, 4, and then we'll run over 1 unit, and then we'll just connect the dots. There's your line. It's that simple. Now you actually can make a little XY table, plot your points and all that business like we did in section 4 or 5, but it's so unnecessary because 0, 0 is your starting point always for these, and then you don't have to, and then you can just use your slope and go up 4 and over 1. Now the reason why these are special is because the b for these, we'll learn what the b is later, but the b is always going to be 0. That's going to be the y-intercept. So for these equations, the b is always 0, and so it makes things easy for us. All right, let's look at b. Y equals 1/3 x. Well, the number that's in front of the x is the slope. So we look at that and we go, okay, so 1/3, that's the slope. So that's how much we rise, and that's how much we run. So we'll start it again, right at the origin, and then we'll go up 1, and we'll go over 3, and make another dot, and then we just connect the dots. And remember what we did with section 5.1. We just said, hey, we're going to go up 1, over 3, and that's how we're able to plot our points and how we're able to use the slope. All right. What about these problems? It says, y varies directly as x, so they established that, hey, we're doing a direct variation problem. And y equals 28 whenever x equals 7. So that establishes kind of what the relationship is between the two variables. So we start them off the same way. We start off with y equals kx. We plug in the numbers that they give us. So we plug in 28 for the y. The k is unknown. We're going to establish that in a second. The x is 7. And now we can figure out the k. So we divide by 7, and that gives us 4. So now we know that the k is actually 4 for this problem. All the time, the k is 4. So if we want to write a very general equation, a direct variation equation, then we can say y equals, oops, just kidding. Y equals, we're not going to write k, we're going to write what we know k to be. Now we know that k is always 4, so our equation, our direct variation equation, that they ask us to write, is y equals 4x. Once you have that, then you can answer any questions that people have about the equation. Like they could give you the x and then have you find the y, or they could give you the y and have you find the x, which is this next problem. It says find x when y equals 52. So we start off with the same, we start off with the equation, y equals 4x, because we know that our k is always 4 now. And now they're telling us that y equals 52, and can you figure out what the x must be in this case? So we plug in a 52 for the y, and then we just solve for x. So divide by 4, and this will be 13. So whenever the y is 52, then the x is 13. You'll notice that this equation, whenever you put in a value for x, you're always multiplying it by 4, which means that y is always going to be 4 times as big, wouldn't you say? Y is always 4 times as big. It establishes the relationship, 4 times as big. So whenever you put in an x, some people just kind of do this in their head. If you put in like a 5 for the x, then you just would have to multiply it by 4, and so then the y would be 20. Hopefully you get the idea there. All right. Let's say, now this next problem is really the easiest one of all. They give you a graph of a line, and they might have the ordered pairs written, or they may not, and they say, hey, can you figure out the constant of variation and then find the slope of the line passing through the points? And you say, the constant of variation. Well, isn't that just the slope of the line? And so you look at it and you go, okay, well, to go from this point to this point, all I have to do is go, let's see, I go up 1 and I go over 3. So that means my constant of variation, my k, is 1/3. It's the same as the slope. So they say, hey, find the slope, and you're like, really? I just found it. It's k equals 1/3. It's the same as the slope. Okay, so the constant of variation, same as the slope. You go up 1, you go over 3. Now, do you have to use the points? Well, no. You don't have to calculate it the way we did with the last section where you subtract the y's, over the x's, but you certainly can to check it. So we can do 1 minus 0, and then we can do 3 minus 0, and then we can get 1/3. So we get the same thing. So the slope is 1/3 as well. Same, okay? All right, let me finish with this application. Let's say a family drove 225 miles in 5 hours. We would like to write a direct variation equation to find the distance traveled for any number of hours, okay? And we're going to always, pretty much always let d equal distance, t equals time, and r is the rate. So we start off with our equation. This is on the final a lot. Distance equals rate times time. So I kind of have it circled still from when I was writing it earlier. Okay, so distance equals rate times time. Well, let's plug in what we know. We know the distance, right? So we know 225 miles. And let's go ahead and plug in the time. So we know that. We know the time is 5 hours. So we can put that in there. And then we can solve for the rate. So the rate equals 225 miles divided by the 5 hours. And so that means that the rate is, and when we divide that, I think we get 45 miles per hour. So that's how fast they're going. If they were able to cover 225 miles in 5 hours, and if we go to graph it, it would look something like this. If we went 0, 0 hours, we wouldn't, have any distance. But in 5 hours, they were able to go 225 miles. So we just could connect the dots and call that good. That'd be a good line. And the rate, or the slope of that line, would always be whatever we figured out the rate is. So the rate is the slope of the line, and that means we would be going 45 for every hour. So we'd be going 45 miles. So we'd be going 45 miles for every hour that we drive. So that's the slope of that line. It's also the k, if you will, the constant of variation. In this case, the rate equals the k. So if we were going to write this really generally, kind of like the d is kind of like your y, and the time is like your x, and the rate is like your k. So we could kind of write this with the d and the t in there. So we'd say d equals, and since we know the k is 45, then we can say d equals 45 t. This would be a way to write it, kind of like your y equals kx. Now, last question. Let's say this same family wants to know how long it would take to drive 360 miles. Well, we would use this equation, and we would just plug in the 360 miles for the distance. So we put in 360 miles, and then we have 45 here. Remember, that was 45 miles per hour, and then we don't know how long that will take them. So we're going to solve for t, and that would be, you can tell it's multiplication, so we divide. So we have 360 miles, and we divide it by 45 miles per hour, and so t will equal whatever that is, so 360. I think it's 9 hours. So it'll take them 9 hours. Okay? So hopefully that will help with direct variation.